Let's look at how we can use a loop to perform what's called a cumulative computation. Before we do that though, I want to tell you about some shortcuts that Python makes available. Let's assume we have a variable age and we assign it the value 13. We can then increase the age by 1 by doing this assignment. Because the right hand side is going to get evaluated, we're going to plug in the current value of age, add 1 to it, and then the new age gets stored back in the variable. And because we do this type of thing a lot, where we're basing the new value of a variable on its old value, there are shortcuts for this purpose. In particular, this line of code here is equivalent to our original assignment, and we're using an operator called the plus assign operator, or the plus equals operator, and it's equivalent to what we did here. Okay? And there's one of these shortcuts for each of the arithmetic operators. For example, there's an operator which is times equals that allows you to do multiplication, and it's equivalent to what you see over here. So we have some variable on the left hand side of the operator, we have some expression on the right hand side. Whatever it is, we're going to evaluate that expression first, then multiply the result by the current value of the variable, and then the result of the multiplication gets stored back in the variable. And it's really important when you use one of these shortcuts that the equal sign comes after the other operator and not before. Now let's look at how we can use a loop to sum a list of numbers. And we're doing it in the context of a function called sum. And we're going to start by defining that function, and then we're going to come down here to the global scope where we have a print statement that calls the function. So we go ahead, we call it, we pass in this list of 5 values, and that gets assigned to the variable vals, and then we start executing the function. And the first thing we do is initialize a variable called result to 0. This variable result is going to gradually build up the sum of the list of numbers. So initially it's 0, but then we have our loop, and you can see we have a loop variable x, and it's going to take on one value at a time from the list vals. So for this particular list, x starts out with the first number, which is 10. We then come down here and we use our plus assign operator to add the 10 to the current value of result, and that gives us the new result. 10 plus 0 gives you 10. Then we go and we get the next value from the list and assign it to x, and then 20 plus 10 gives you 30. Then 30 gets assigned to x, 30 plus 30 is 60. Next value gets assigned to x, 40 plus 60 is 100. Next value gets assigned to x, 50 plus 100 is 150. And then we go back and there's no more values in the list, so we're done with the loop. And now this value 150 is indeed the sum of these 5 numbers. And do you see how we gradually built it up? And then we're going to go ahead and return that sum. That return value gets sent back. It replaces the function call, so it's as if we had said print 150, and so that's what we output. Now this is what is known as a cumulative computation, what we did with our loop. And result, that variable, is referred to as the accumulator variable because it's going to gradually accumulate or build up whatever it is that you're trying to compute. And then you can see here that the way we're doing that is by using a loop, and inside the loop we add one value at a time from the list to that accumulator variable. And we saw how that worked for our example. Now there are actually two different variants of for loops. The one that we saw in our sum function is what is sometimes called an element-based for loop, because the loop variable, x, takes on one element at a time from the sequence. So in this case, imagine that we were summing up these 4 numbers. X would take on the actual elements one at a time, and we would add them to the result. The second variant is called an index-based for loop. So here is a rewrite of our sum function in which we use that approach. So here you can see that I, which is now our loop variable, it's not taking on the values from the list, rather it's taking on values from the result of this range call. And we're passing into range the length of the list. And so range is going to give us a list of index values. So for example, if this was our list, range would give us these 4 values, 0, 1, 2, 3, which are the index values of the elements. And I is going to take on those index values. And so down here, when we do the sum, instead of having the loop variable itself, we have to use the loop variable as an index into the list to get the actual value. Now, we wouldn't necessarily take this approach for this particular problem, but it turns out there are problems in which this index-based approach is the better one. But for now, let's just trace through what happens to make sure it's clear. So this time we again define the function, come down and call it. We pass in the list of values. So all of that's the same. We assign 0 to the result, to the accumulator. But now, when we get here to our loop header, we first need to figure out what range is. In this case, it's range 5 because the length of vals is 5. And remember, that's equivalent to 0 through 4. And so the first value that the loop variable takes on is 0. So it's not taking a value from the list, it's taking an index value being produced by range. We then come down into the body of the loop and we're adding vals I, which is val 0, and that's the first value in the list of values. So that still gets added to the result. We're going to get the same gradual buildup here. It's just sort of a two-step process. You first get the appropriate index into I, you then use vals I to get the value, and then that value gets added to the result. So we get the same results as before, but using this index-based approach. And then when we run out of values in range 5, we stop the loop, we return the result, and we print it.